Welcome to Unit 3, Day 10. In this lesson, we're going to discuss something called non-real roots. And basically what we're going to do is connect what we learned on Friday about complex numbers to the rest of the unit in which we are talking about parabolas and their graphs and the different things that we see on their graphs. To start, I just want to do a quick reminder, and this is related to your drills that you just did. If you encounter a negative sign inside a square root, before Algebra 2, this is something that you couldn't simplify, but as we learned on Friday, in fact, you can simplify it, and what you should do is factor out a -1, and then replace -1 inside the square root with an I outside of the square root. So for example, if I were to look at something like the square root of -5, I would rewrite that as the square root of -1 times +5. And the square root of -1 is I. And then 5 stays inside the square root because it's not a perfect square and can't be simplified. And usually what we would do is we would put the I at the back and just being careful that it's not inside the square root. Similarly, if I wanted to take the square root of -16, I would rewrite this to be the square root of -1 times +16. And then both of these have square roots. The square root of -1 is I, and the square root of 16 is 4. And so the answer is just 4i, and there is no square root left. 24 is kind of a combination of both of these. When we simplify the square root of -24, we can factor out a -1. And then 24, I would split into 4 times 6. And the reason I do that is because 4 is a perfect square. So the perfect squares can come outside of the square root, and we get 2i outside, and the square root of 6 is stuck. And you can write it this way, or sometimes we would write it as 2 root 6 with the I at the back. The reason this skill is very useful is because we've seen a couple instances where we try to find the roots of a quadratic function and then something weird happens. Let's look at example A. You will notice that this is a function that's in vertex form because you have the parentheses. And that's fine. When we find the roots, we know that what we're really trying to do is we're trying to get this whole equation to equal 0. And so to do that, I'm going to use the square root method. We have a number of options. We could factor, we could do quadratic formula, but when I see that there's only one x, I remember that the square root method is easiest. So here's the equation that I'm trying to solve. I've got -2 times x plus 1 squared minus 8 equals 0. And my first step is going to be, my goal here is to isolate the parentheses so I can take the square root of both sides. And in order to do that, I will start by adding 8. And then I'll divide by -2. When I do that, I end up with x plus 1 squared equals -4. And if this were a problem from Thursday's lesson, we would go on to take the square root of both sides. And we would remember that there are actually 2 square roots, so this is going to split my equation into 2 pieces. The square root and the squared symbol cancel each other out, so we have x plus 1. And then it's going to equal the positive and negative square root. But I notice now that there's a negative inside. So this isn't just going to be 2 and -2. The square root of -4 is either 2i or -2i. Last step to get x by itself is to subtract 1 on both sides. And we get 2i minus 1 and -2i minus 1. And those are the roots. But you'll notice that they're not real numbers. These are imaginary numbers. And some quadratics have imaginary numbers as roots. We'll look at another example and then we'll talk about what this means. Example B is in standard form, which means that instead of using the square root method, we're going to want to either factor or use the quadratic formula. And just real quickly, we'll review here. Factoring would mean we need to find 2 numbers that multiply to 8 and add to -2. But it turns out there's nothing that will work for this quadratic, so we're going to use quadratic formula. Remember that a is 1, secretly out front. And here I've got my quadratic formula set up. I'm going to plug in negative b up front and a and c inside, as well as a on the bottom. When I simplify this quadratic formula, we get 2 plus or minus the square root of positive 4 minus 32. And don't forget the 2 on the bottom. Positive 4 minus 32 is going to be negative 28 inside the square root. And little bells are probably already going off in your head because you know what that negative means. But in addition to simplifying the negative, we're also going to remember that 28 is 4 times 7, and 4 is a perfect square. So when I simplify this square root, which is my next step, I get 2 plus or minus 2i, and then the square root of 7 is what's left over inside. You'll probably remember that the 2 on the bottom must simplify both terms. You can split it into 2 pieces if you like, or you can probably see what the answer will be here, which is 1 plus or minus root 7 times I, because the 2's cancel each other out. Now, I want to clarify something that I think I didn't do a good job of last week, which is that when we write this plus or minus symbol, we're actually writing 2 answers, even though it looks like 1 answer. So for today, I'm going to ask you to split this out so that we can really see what the 2 answers are. They're not real roots, but there are still 2 roots. The first one is when you take the plus, so it's going to be x equals 1 plus root 7i. And the second one would be to take the minus, so x equals 1 minus root 7i. We'll pause the video here so that you can complete the practice problems on the next page. There are 6 of them. When we are done, we'll take a look at the answers. Here's the answer to number 1. And number 2. And number 3. Number 4. Oop, this should be number 5, although it says number 6. And this is number 6. Oops, sorry. There we go.